Hi, Chris Good here. Here's part two of the week four essentials video lecture, and it's on stimulants. We already talked about cocaine in part one. This is amphetamines. Talk a little bit about the history. There was a plant, still is a plant, called ephedra. The Chinese name for it, and I'm sure I'm pronouncing this incorrectly, is mahuang. And the active ingredient in that is a non-amphetamine stimulant that's called ephedrine. Um, Ephedrine is still used medicinally. It's used to temporarily increase blood pressure. You might need to do this as an anesthesiologist or during surgery or something like that. And it can be toxic or fatal even at the doses that occur naturally in the plant if you combine it with other stimulants, even something like caffeine. Again, doses is everything. Ephedrine is what we call, and amphetamines are as well, a sympathomimetic drug, and that means that it stimulates the sympathetic branch of the autonomic nervous system. The autonomic or automatic nervous system is that branch of your nervous system that governs your basic body functions like respiration rate or heart rate, digestion, things like that. And normally when you're just sort of sitting around, it's the parasympathetic branch of that nervous system that's active. It's the sympathetic branch of the nervous system that takes over under stress. So in that fight or flight sort of situation, your sympathetic nervous system is activated, your parasympathetic nervous system is deactivated, and ephedrine is a drug like amphetamine that activates this fight or flight type of response and that part of the nervous system. So there was a newer synthetic version of the drug that's very similar to ephedrine, and it's called amphetamine, and it was patented in 1932. It was originally used medicinally to treat asthma, and it was used to treat narcolepsy, which is a fairly rare mental disorder that involves falling asleep spontaneously. It's been used to treat hyperactivity in children. We're going to talk about that again a little bit later. It seems kind of odd. Why would you give a hyperactive child a stimulant? But there's actually a good reason why you might do that. And otherwise, it's just used as a stimulant in the same way that you would use other types of stimulants. It's used to increase alertness, to delay sleep, to keep your energy up. And that's how amphetamine was used. It was used in World War II to fight fatigue. In the 1960s, using amphetamine and heroin together at the same time became popular. That's known as a speedball. Most street amphetamines in the 1960s came from prescriptions. And as a response, the federal government sort of cracked down on amphetamines. A lot of lookalikes appeared on the market. Some users switched back to cocaine, and you see this a lot as you crack down on one stimulant, another one grows more popular. And so the illicit manufacture of methamphetamine grew as a result in the 1960s and into the 1970s. And it's recently experienced a resurgence. So initially, limiting amphetamine availability increased the number of illicit laboratories making methamphetamine, and has become even more popular in the past 10 years or so. As dangerous to manufacture, it's associated with toxic fumes, toxic residues. Many of the reagents that you need to extract the precursor from pseudoephedrine, which is the over-the-counter nasal decongestant, that's a methamphetamine precursor. Many of those reagents are flammable and explosive, and in order to complete the reactions that you need to create methamphetamine, you have to heat it. So heat and illegal drug manufacture and explosive reagents are bad combination. So in this picture, you can see this is a raid on a meth lab that's in a residential neighborhood. You can see these people are just walking down the sidewalk. And the blue pools that you see in the background are decontamination pools where people will have to be sprayed down even inside their hazmat suits after they clean up all of this hazardous waste. Because that's what it is. It's hazardous waste that had to be hidden on a residence here in a residential neighborhood from a meth lab someone had set up in their garage. This is the end product. These are methamphetamine hydrochloride crystals. Unlike the hydrochloride salt of cocaine, methamphetamine can be ignited and it's smokable. So it's also called ice or crystal meth, and these are the crystals. This is what is smoked as methamphetamine. Its resurgence began in the western United States and then sort of spread east, and now it's sort of everywhere. And there's a very popular TV show now called Breaking Bad about a chemistry teacher who begins to manufacture methamphetamine on his own, and so methamphetamine manufacturers become quite well known as a result. Let's take a look at the molecular structure of amphetamine and compare it with that of cocaine, dopamine, and some other molecules. So you see here in the top middle, this is the dopamine molecule, and you don't really need to know anything about chemistry to recognize the similarity here. I mean, they have basically the same structure. All of these molecules do. So this is dopamine. To the right of it is norepinephrine, and it's very, very similar. There's really only one position where you see this red dot over here on norepinephrine. There's everything about the molecule is the same except for that red dot and the brown dot attached to it. So the red dot represents an oxygen molecule, the brown dots are hydrogen, the blue are carbon, and the purple are nitrogen. And you can see that except for this one little hydroxyl group, the red dot here on norepinephrine is very, very similar to that of dopamine. Amphetamine looks almost exactly like dopamine, except this amine group, the nitrogen over here, has been moved from one position to another. So it very, very much resembles dopamine. It also looks a bit like cocaine as well. There are other molecules that share the amphetamine sort of backbone, if you will. You can see methamphetamine on the right, and that gets its name because it has this extra carbon atom stuck to the purple dot over here. We call this a methyl group, so this is methamphetamine. Phenylpropanolamine is another molecule that looks very, very much like norepinephrine. This is ephedrine, which we've already talked about. Again, all these look very, very similar. And amphetamine has a similar mechanism of action to that of cocaine. It blocks a transporter, but it blocks a different transporter than does cocaine. It still acts presynaptically. We talked about how cocaine is blocking these transporters involved in reuptake. Well, there are other transporters that are involved in grabbing norepinephrine in the presynaptic neuron and packaging it into vesicles, and it actually makes these run in reverse. It grabs dopamine out of the vesicles and puts it back into the synaptic cleft. So it basically empties out these vesicles into the synaptic cleft and putting more dopamine into the synapse. So it does this with norepinephrine as well, but it's very difficult to tell the difference between the behavioral effects of amphetamine and cocaine. So let's talk about some beneficial uses of the drug. You might think, well, these stimulants, they're used to stimulate the central nervous system, and it gives you feelings of euphoria, and at the right doses you really feel up. Why couldn't we use this in depressed people? Why do we use these other antidepressant drugs? Well, the problem is that there's a rebound effect afterwards where you end up lower than you started off with. And in somebody who's already depressed, that could be really dangerous. So most people operate mood-wise in this kind of middle range, normal range, somewhere in between happy and sad, with some variability in between, throughout the day, throughout the week. And if you start off in that range and you get up into the euphoric area briefly while you're using these stimulants, and then it comes back down, you're still sort of in the normal range even if you go below where you started off with for a little bit. If someone starts off depressed though, yeah, stimulants like this can get you up into the happy range, but then the crash you experience later on can push you even more down than you were before. And in a disorder like major depressive disorder, that where suicide's a possibility, that's really the last thing that you want. So, for methamphetamine, those peak effects come if after smoking, just a few minutes right after smoking it, and the half-life is around 10 to 12 hours for amphetamine, 4 to 5 hours for methamphetamine, and so it's relatively long-lasting um, uh, effect. Um, it's also, we mentioned that it's been used to treat attention deficit hyperactivity disorder. This is a disorder that's characterized chiefly by problems with inattention. And the hyperactivity is related to that, and also impulsivity. So these have to do with the inability to focus, and that's what you see is the chief complaint about folks diagnosed with ADHD, is that inability to focus on one thing. Stimulant medications, like amphetamines, and like the non-amphetamine stimulants like Ritalin, which is methylphenidate, it also acts, that drug incidentally also acts as a norepinephrine and a dopamine reuptake inhibitor. That non-amphetamine stimulant, Ritalin, blocks the dopamine transporter very much like cocaine does. So one of the cognitive effects of stimulants is that it increases concentration and improves cognitive performance. It allows people to focus, and at very high doses, you can focus on things that really don't make a lot of sense, like counting the number of cracks there are in your floorboards, or counting the number of cornflakes there are in a box of cereal. But that ability to concentrate on that one thing, that's what's missing here in those folks diagnosed with ADHD. And remember, not only is there a problem that's addressed by one of these cognitive effects of the stimulant, but you're also dealing with a population where there may be a dopaminergic system, a catecholamine system, that's not functioning normally. And the effects of the stimulants may reverse some of that. However, because of side effects, concerns about a risk of abuse, particularly for the amphetamine type stimulants like Adderall, which is a mixture of amphetamine and dextroamphetamine. Other treatments for this disorder are being studied. For other types of performance in normal folks, well, the effects of stimulants are different depending on the demands of the task. For simple tasks, represented by this orange line right here, performance increases the more you're aroused. So the more stimulated you get, from sleepy to alert to really excited, doing something simple, your performance is going to improve. However, something that's complicated, you get this inverted U sort of shape where if you're overexcited, something that's complicated, your performance will be degraded. And that's a pattern that you see for pretty much every stimulant, whether it's legal or illegal, or whether it's prescribed or over the counter, or a cup of coffee or cocaine. The more stimulated that you get, if something's complicated, your performance is going to be diminished. Although you can't really do it while you're very sleepy either. So, under some circumstances, stimulants may slightly improve athletic performance, and so there's the potential for abuse there as well. And so they've been banned. Many stimulants have been banned or regulated in official competition. Let's talk more about the acute toxicity for the amphetamines that may come in the form of behavioral toxicity. So people feel an increase in feelings of power, may develop delusions like paranoia, or delusions of grandeur, which is the feeling that you're sort of at the center of some vast conspiracy or have some special knowledge that nobody else does. There's potentially the risk of violent behavior when when using very high doses of stimulants, and very high doses might destroy those very neurons that are being affected by the drug. So it may be neurotoxic as well. There may be contaminants that are formed during manufacture of illicit stimulants like methamphetamine that could have their own effects, toxic effects on brain cells and other systems like the liver or kidneys or the circulatory system. There may be a risk of developing movement disorders like Parkinson's disease. Remember, that's a disease that involves dopaminergic neurons in the membrane and that nigrostriatal pathway from the substantia nigra to the basal ganglia. Chronic toxicity from using high doses of amphetamines for a long time include paranoid psychosis. There's a greater risk among those who inject or smoke the drug than those who are using it orally. Um, Repeating stereotyped actions or compulsive behavior, and we already mentioned an example like spending a night counting cornflakes. Those can be other behaviorally toxic effects. The other types of physiologically toxic effects of the drug are very, very similar to those of cocaine. You know, the cardiotoxicity, the risk of stroke, the risk of heart attack, the risk of respiratory arrest. All of those go for amphetamines as well as they do for cocaine. And we'll wrap it up right there. And we'll see you next time when we're talking about depressant drugs.